I'd like to welcome everyone to our presentation today. My name is Bob Kirk with the Canadian Apparel Federation, and we are here for a presentation on warmth and thermal insulation, and that'll be presented by Sai Chang, who will start his presentation very shortly. I'd like to welcome everyone here today. Couple pieces of housekeeping. The presentation today will be recorded, and we will have that available within 24 to 48 hours. So that's the first thing. People can sort of enjoy the presentation as it is given. During the presentation, if you have questions, you can ask them. There's a question icon in your control panel, and that's usually in the top right-hand side of your screen. So those questions are received, we store them, and if for any reason they can't be answered during or after the session, then we will pick them up at a later point. So again, the important thing is that the session will be recorded. Couple things as well is that there will be a survey right at the end asking for you to provide some feedback. And again, please do so we can improve this in other sessions. So again, for those people joining us late, the session is being recorded. Number two, you have the ability to ask questions throughout. And again, we'll generally pick those questions up at the end. And if there's a specific reason for interrupting the presentation, we'll do so in order to help with the clarity. Okay, so the bottom line is I encourage everyone to take advantage of this opportunity. Sai is a very engaging presenter, knows the subject very well. He'll walk you through the whole presentation, and again, toward the end, we'll try to pick up those questions. Very good. So without further ado, I will ask Sai if he's on and he can get started.
Thank you, Bob. I hope everyone is doing well in this pandemic period. I know some of you are joining in from Asia and Europe as well. Wherever you are based, thank you very much for the opportunity to discuss this important question and subject. So without further ado, let's proceed. Okay, so I put together 5 different segments in this presentation. In the first intro part, I will briefly introduce HINMAX and myself, and then I'll explain to you about the HINMAX's COVID-19 virtual program. And then in the second segment, we'll review how the thermal insulation works. I'll be focusing on the passive heating and important factors that relate to the passive heating, and the quantity, size of air pockets, and the organic versus inorganic. These are really important knowledge for us to have in order to have a comprehensive understanding of how thermal insulation work. And the next section will be the test data versus real-life warmth. Now, some of you might have to deal with emails or phone calls during this presentation, but I would like to ask you to pay attention for this section, because this, if you get one thing out of this presentation, it will have to be this section where I'll be sharing with you that test data not necessarily translate to the real-life warmth. And also the next section, I'll briefly discuss other technologies related to warmth. For example, active heating, phase change material, and reflector, etc. And then towards the end of the presentation, I'll be talking about the HINMAX technologies, which relate to what we'll be discussing beforehand, so that you can understand how relate with each other, and also the metrics and environmental and social responsibilities. And towards at the end, we'll finish with Q&A. And the objective Objectives of this presentation is understanding the important principles of how thermal insulation technology works. And we also offer brand or company specific or college webinars. I know that some of you are listening in from colleges, and so the subjects will be customized to focus on the products and technologies of specific brand or company or needs of college. So like some of you might have questions, but you might not want to post those questions while your competitors might be listening in. And for those purposes, we will offer this company-specific webinars, and the time, we can set the time based on the convenient time of each organization. So now, from now on, let's get into how the thermal insulation works. Now, before I begin, as I mentioned earlier, thermal insulation was not a part of the curriculum available in the program. But if you think about it, this is a really important part of your wardrobe. Most certainly, it's the most voluminous items, and cost-wise, it's quite high as well. And but the textile engineering program that I took, they didn't offer anything related to it. And recently, I worked with the Fashion Institute of Technology based in New York. And in their fashion program, they didn't have this type of program. So the students greatly appreciated the knowledge that they gained. So I'm sure that you will be able to gain quite practical knowledge that will help your job or your whatever you need to do with industry. So here I put together some important factors for warmth and three-dimensionality, quantity, and size of air pockets, and so on and so forth. Now, as I mentioned earlier, the star marks on the left-hand side will indicate that I will offer these subjects in different webinars. And by going through these basic knowledge about how the thermal insulation works, some of the questions that we can answer, for example, why a certain type of material is used for a certain type of applications, how a design spec impacts the warmth, etc. And I randomly selected a lot of questions that I got from my customers in the past. And so the list that I'm showing here is a random selection of those. Of course, there can be so many different questions, and just please, consider them as examples. So one of my friends told me, well, you know what? I bought a really expensive winter jacket, and it's supposed to be really warm, but I get chills in the winter time very easily, even wearing this this jacket. Why is it? So we can answer those questions with this program. And why do we tend to overdress? So people talk about layering effect and why it's important to layer. Sure, it is important to layer, and I'm not debating that. But if you think about it, if we do a proper job with our outer layer, then the burden of having to use this type of heavy sweater underneath may be reduced. So once again, by going through this presentation, you'll be able to think about it and answer. And of course, there are many more questions that can be posed like this. So the passive heating, it's most widely used method of thermal insulation, and I think it's the most complete package that they can provide. And basically, it uses our body heat as the energy source. And it stores body heat in air pockets of thermal insulation material. So I showed you, I'm showing you two typical examples of thermal insulation. One is the batted material, and the other one is loose fibers. So in this case, it's a down feather material. Now, so here is the important variable. How important is the material to provide a structure to store maximum quantity of dry or drier air? So, so this is a big question. But then if you just look at this sentence as the important variable, you might think then bubble wraps can be a good insulator, and you can just wear this and go outside and expect for you to be warm, but it doesn't work like that. So this is the science. This is where the science comes in. I took this image from from the internet, and basically it shows the bulk insulation heat flow. So where the heat flow is marked here, so this is the body side, and the pockets of trapped air is here, and then a small amount of heat is leaking. So this is how bulk insulation work. Now, the other part that I want to talk about is dry air. Why is it important? Whether it's dry or less dry, why is it important? Here, it's a thermal conductivity chart. I'm not going into the deep science about this, but I think you can easily understand that the air here in the dry form, oops, sorry. So the air in the dry form has quite low thermal conductivity, whereas water, it has much higher thermal conductivity. So if you actually think about the fact that you can put your hand in the oven with 400 degrees Fahrenheit or 200 degrees Celsius without having any protection, unless you touch the container in it. But you cannot put your hand in the water with a temperature above 50 degrees Celsius. That's because thermal conductivity of air is much lower. So using the dry air is a really good way of insulating your body heat. So I put some examples here. Sorry about these marks here. So I put 3 examples. One is a thin shirt, and then the heavy sweater, and a jacket with proper insulation, thermal insulation. Now, here what I want to, I mentioned earlier that a friend of mine mentioned, I bought an expensive heavy jacket. Why is it not warm? I'd like to emphasize here that it does not necessarily correspond to the weight. So the jacket on the right-hand side may be much warmer than the heavy sweater in the middle. So then how do we measure the warmth or thermal efficiency? And I'll start with the CLO value here. So in the CLO value, the test chamber is here. You can see on the bottom that there is a heat plate, and then there is a temperature sensor. And let's say you cut the back panel of the sweater you saw earlier, and then you put it on the heat plate, and then start heating up the heat plate. And then there is temperature 1, basically the temperature of the heat plate, or temperature 2. And so if the thermal efficiency of the material that you are testing is high, then the T2 would be low because the sample contains a lot of heat inside. So basically that's how this works. So if you are in the footwear industry, basically the heat plate is a shape of a foot, and you can put the footwear into the thermal foot and then measure the thermal efficiency. So it goes same way whether it's a thermal hand or mannequin. And the measurement units that we use, typically in apparel industry, we use CLO. And in home textiles, we use TOG. And in constructions, we use R value. So your house needs to be properly insulated in order for you to minimize the cost of heating in the wintertime or cost of cooling in the summertime. So it basically works the same thing. Now, when it comes to the down feather material, or some of the loose fibers that you use for thermal insulation, we don't use the heat plate. Basically, we put a certain quantity of the material into a predefined volume of a cylinder, and we measure the volume. Obviously, the higher the volume, the more air is contained. Therefore, the thermal efficiency is higher. So that's how we measure the thermal efficiency. Here, I'd like to present to you some of the raw material options and the three-dimensionality, because that's really important element for trapping air and quantity of air. In fact, these two closely correlate to the volume of thermal insulation material. So one thing that is quite unique about down feather material is that it comes with a really optimum three-dimensionality to create a lot of small air pockets within itself. So this is a single piece of down feather material, and also the size of air pocket is really important. And so I'll explain to you with this picture here. This is a microscopic view of down material. And you can see there are so many small hair, and these are not even visible with your eyes. And so if this is, again, single piece of down. And when you think about crisscrossing these material with many pieces of down, the quantity of air and the size of the air pockets become very, very small. Whereas in order for us to create this type of thermal insulation, these types of thermal insulation material, we have to use these types of fibers to crisscross each other. And if you compare these fibers with down material, you can see that it's a lot more two-dimensional. The cotton has a little more three-dimensionality because of the curves that it creates. But once again, it doesn't fill the space like the down feather material does. So for us to create the three-dimensional shapes, we have to think about the 3D space, and we have to use a lot of fibers, small fibers, in order to create these air pockets. So when you look at the thermal efficiency point of view as examples, in the same area, if you have a higher volume, typically it translates into higher thermal efficiency. And it goes same as the down feather material. 550 field power is a lot less thermally efficient than 900 field power. And another important factor that we have to consider is the organic versus inorganic. So down feather or wool that you saw earlier, or silk, all these organic materials, they get impacted by moisture in the air or the sweat from our own body, and it can have a very negative impact. So bacteria is one of them. Microorganisms can grow if they have a proper environment. And unfortunately, our body provides that environment. So the sweat from our body, it contains a lot of organic matters, and ammonia and fatty acid are some of them. And the bacteria can live off with this. In fact, one of my customers told me this story about her taking a family camping trip, and she used a sleeping bag that her brother used to use. And the next morning, she could not even open her eyes because her eyes were all got swollen because of the sleeping bag, and the bacteria can really attack. And I had another customer who said, oh, she took a bus somewhere, and then the guy who sat next to her in the wintertime, he smelled really bad, and it sounded like a bacterial smell. And even if you don't smell it from your blankets or comforters or pillows, it doesn't mean that the bacteria is not there. Depending on the density and the type of bacteria there is, you may or may not be able to smell, but this can be a source of your flu in the or cold, your in the seasonal changes and things like that. So this may impact you more than you think. And the weight and thermal efficiency ratio. So down is the lightest material and the most thermally efficient in its optimal state. But when the moisture gets in, it's a different story. And in contrary, the synthetic material, it's heavier than the natural organic fibers or down, but it's not impacted as much as organic material in terms of the moisture. So there are a lot of things to consider here. Compression recovery, same thing. When we use organic material, it can recover the compression much easier because based on the moisture regain, it can recover its original shape easily, but it's not as durable as synthetic fibers, so it can break down much easier. So in the end, synthetic material may be more durable in terms of providing the warmth. So obviously there are a lot more than what I listed here. And with today's technologies, there is no one material that will satisfy all the possible scenarios. So that's why we have to think about the applications and the end use of it. And so, for example, if you were to build the jackets for high mobilities and the people sweat a lot, and I put some examples of military and workwear or person who naturally sweats a lot. So for these, organic may not be as good as inorganic. But then there may be other applications where the organic is considered better. Now, here is the part that I emphasized as the most important segment of this presentation. So one way or another, everybody in our industry deals with some form of test data. But does it translate to the real life warmth? That's the big question. So high CLO value, you're using high field power material, but is it guaranteed to have to produce warm product? So let's look at some of the scenarios here.
Sai, I have a quick question,
Sure.
two or three little questions, and I'll roll them into one. Can you just maybe specify exactly what CLO and TOG, what the abbreviation stands for? So that was one question.
Mm-hmm.
Uh, and can you equate fill power with CLO value and vice versa?
That's great. Thank you. That's a great question, Bob. Thank you. So CLO is like meter. It's the name of a unit. So it doesn't stand for anything. TOG is same thing. So when you say meter, we understand how many the distance between two separate points, and the CLO works the same way. Now, the consumers, I'll cover this towards the later part of this presentation. Consumers or non-experts are not able to easily understand CLO. So this is one of the challenges for us in the industry to convey the story of warmth to the consumers. So I'll cover that a little bit later. To answer your question, second question, Bob, I know that there are some companies out there which put out some specific numbers saying field power such is equivalent to CLO such, vice versa. But as you saw earlier, they are two different test methods for these two different types of material. So, and there is not an equation to convert CLO from CLO to field power or vice versa. So there is no standard way of doing it. Of course, they're closely related because they both measure the thermal efficiency provided by the quantity and size of the dry air pockets. That's what it is. But in essence, there is no direct comparison. I can come up with a method to put the down feather material, for example, in a certain containment and try to do a CLO value, but I don't know how useful that information would be. But they're correlated, and we can develop some ways of understanding between using a certain field power and certain CLO value batted material, but there is no direct correlation. I hope that this answered your question, Bob.
Sure. Yeah, I think that's good. And again, if there's more detail needed, they can reach out to you independently.
It sounds good, yes. So here we're going to talk about cold spots and real life warmth. So I'm showing two different types of insulation material. One is the base material, and the other one is the down feather. Now, we never use these as is. So we always have to stitch them. And the question is, when after stitching, what happens with the warmth? Let's say you are quite cognizant about how consumers feel in terms of warmth. And so you decide to measure the CLO value of this structure, if you will. But the test data that you get out of this is the average value of the entire structure. But if you think about this, cold air hitting the high volume area will have a lot higher thermal efficiency, whereas if the cold air hits the stitch line, there is no air pocket there. So the thermal efficiency is very low. The thing is, our body does not calculate the amount of air coming through the stitched areas versus high volume areas and average out, and then that's how you feel. It doesn't work like that. The part where the cold air hits through the specific area, you feel cold there. That's how our body works. So this is what I mean by real life warmth versus the test data you get from whether you test it in the form of a thermal insulation or the average value, CLO value through the structure. Now here I'm showing you two images of a typical garment or sleeping bag or whatnot. So you will see a lot of cold spots represented in the colors of red or yellow. And that's where the heat leaks. Once again, our body does not calculate the average value of cold air coming in. It just feels wherever the cold air comes in. So this is one example. And also another example is a clustering. I took this picture from a trade show, and a company was obviously trying to promote this garment design. And if you actually can take a close look, there is a huge cold spots here. So all these are cold spots that I'm drawing here. This is really huge. I know why some people use bonded structure, and in fact, in terms of the down feather product, it prevents the leaking of down through the needle holes, and that's maybe one of the reasons. And the second reason might be that it's a design element. But for winter garment, this would not give you a proper warmth. In fact, something like this would be a good example of why you have to layer heavy sweaters or thick shirts inside and things like that. So this is an example of a blanket, a comforter, and you can see the dark area where the down feather is clustered, and there are light areas where the down feather is almost non-present. Now, after a brief introduction, brief discussion about other technologies in the next one slide, I'll cover a little bit of HINMEX technologies and how we can address these issues in real life warmth. And the other technology section here, so I listed 3 different types, and there could be more: active heating, PCM, or reflector. And now, if you think about, you can actually use a common sense whether how a certain type of technology can impact you. And for example, if you use active heating, if you actually use active heating without any heat diffuser, which is normally passive heating material, then areas where the heat lines are located, you will feel too hot, and other areas will feel too cold, and so there is a limitation there. And the PCM material here in this graphic image that I got from the internet, it shows water as an example. So when the water is in the ice form, and when the temperature goes up above the melting temperature, it starts melting, but the block of ice will remain at the 0 degrees Celsius until it completely melts. So that's how the PCM material works. But if the PCM material has a lot of limitations as well, we have to think about at what temperature point it provides that steady temperature, and how long does it last. And those are the questions. And the reflector, in terms of the reflector, these are the technologies that addresses one of the many, one of 5 different ways of how we lose the heat. It's only addressing the radiation part. Once again, these can be a separate webinar seminar, and I'm planning to cover these in future webinar. And these material almost always have to be used with passive heating material. And so those are the principles of how basic thermal insulation works. And in the future, I will cover more details, because some of these subjects need to be explained a lot more details, and we will have opportunities to discuss those things together. So some of the HIMEX technologies. So today, I'm not going to cover all of HIMEX products and technologies because there's a lot. But what I wanted to do today is to show you how we took different approaches from the typical industry approach, and how we have a different engineering principles. And these, I'm using it with graphics and test data, so I think it will be easy for you to understand. So typical industry approach here. Industry has long been promoting the use of microfibers or hollow fibers. The idea is that smaller sizes of fibers will provide a smaller pocket size. We talked about the sizes of air pockets earlier in the down section. And hollow fibers, same thing. The air inside fibers add the quantity of air. Now, this sounds right, but we didn't think so, and so we took a different approach. So in our NMF technology, it stands for no microfiber technology. So we use no microfibers and no hollow fibers, so you don't see these types of very fine fibers in our structure. We don't see the hollow inside. Now, the reason why we took a different approach is because we thought the structural integrity by using stronger fibers provides more volume. So in other words, you lose more by using weak fibers, very fine fibers, or hollow fibers, because there is no core strength from the hollow fibers, you lose more than you gain. So basically, our strategy is to create the maximum volume there can be. And I'll give you an example of the quantity of air that you can gain. So typically, the high volume thermal, there are many different types of thermal insulation material. And there are some with high volume, some with lower volume, depending on the applications that you go for. And so when you talk about high volume material, people say it's 90 to 95% air it consists of based on the volume. Now, let's do a quick calculation of how much air gain you can get from hollow fibers. Let's say that the density of fibers is only 10% for the volume. So it's 0.1 multiplied by, let's say, 50% of the fiber inside is hollow space. So it's a 0.5. So if you do the calculation, it's only 5% gain that you get. These are all very general numbers, because 50% of the hollow space for the diameter, it's actually quite difficult to attain for the hollow fibers. Anyway, so the maximum you get is 5%. But then if you lose more volume than 5%, because there is no integral structural integrity, because they are weaker, then you lose more than what you gain. So I'm actually doing this as an analogy of a beer bottle. So let's say you have two different beer bottles, one with a smaller bottle opening, and the other one is a larger bottle opening. So the one you see on the left has a smaller opening, as if you're using microfibers, and one on the right, you have a larger opening, but it may take a lot longer for the bottle on the right to drain, because it has a larger capacity of beer inside. So this is essentially the strategy that we took. And plus, compression recovery. This is a very important portion of how durable your product is, because if you don't want your garment or your sleeping bags, whatnot, to reduce its volume after a couple of uses or a couple of washes. So the compression recovery is a really important part of the durable quality of your product. Another part is microplastic contamination. Now, I put up a slide here discussing the serious issues stemming from the microplastic contamination. The pollution of freshwater and the seawater habitats is heading here. So if you look at this, an average washing load of 6 kilograms could release an estimated 137,000 fibers from polyester cotton blend fabric, almost 500,000 fibers from polyester, over 700,000 from acrylic, and those fibers are added to the general microplastic pollution. Microplastics are found in 93% of bottled water around the world. Beer, on average, has 4.05 man-made particles per liter. And ingesting microplastics could cause a number of potentially harmful health effects, not only for humans, but also for the animals. So this is a really important subject that we are becoming more aware of. And this is another reason why we decided not to use microfibers or hollow fibers, meaning weaker fibers. So this is an example of the engineering approach that we have taken. Now, then how's your thermal efficiency? So if you look at this bar charts here, we compared our Hinmax material with a widely known, one of the companies considered as a leading company in the industry, and we used the top premium quality of their product in each weight category here. And you will see that in each weight category, we outperform the competitive product. And if you look at the more higher weights here, 4.4 versus 6.8, and our 300 GSM gives you 7.7 CLO value, which is remarkable. Just to give you an idea of the CLO, you might actually, we were able to achieve this without microfibers. So this is an important part of our technology. And some of you might wonder, then 1 CLO, what does it equate to? You know, how much is 7.7 CLO? So I put together this presentation file. So if you think about a typical material used in business attire for a man, of course, he has briefs and t-shirts and everything. And if you actually add up the CLO value, this man is wearing CLO value equivalent to 1.0. So CLO value 7.7, meaning that this man is wearing 7 pieces or 8 pieces of jackets and 8 pieces of everything. So that combination of that many clothes will probably weigh 20 kilogram or 50 pounds. Now we can achieve that with only 300 GSM of heat max. So this is quite remarkable. Now here, I will show you another example of a different approach that we took. So I'll play a small video. It's only 30 seconds. If it lets me to play, it doesn't. So let me see if I still have that. Well, maybe because of the data transfer rate, it doesn't play. So you know what? I will send you the link because it's on YouTube. And basically what it shows is that a competitive brand, the leading brand in the footwear industry right now, their surface structure is such that the fiber structure gets easily damaged. And with a little bit of abrasion, the fibers come off, and you can see that clearly in the video, whereas HinMax material doesn't do that. Now, if you consider the fact that the integrity of the fiber structure is really important part of thermal insulation, this type of weak fiber structure is certainly not a good thing. And in the manufacturing environment, these damages can easily occur. Once again, I'm sorry that the video doesn't work, but I will send it to you later. And here, an example of footwear performance in temperature rating. And so we compared competitive brand versus HinMax material, 200 GSM versus 200 GSM. And you will see that with HinMax material, by the way, this is done by one of my clients, and they use the same design and same material, 2 different pairs, one with a competitive brand, the other one with HinMax. And they were able to get minus 50 or minus 58 degree Fahrenheit temperature rating with HinMax. And with the competitive brand, it was only minus 40 degrees Celsius or Fahrenheit. Now, they told me that they were never able to reach minus 50 degrees Celsius with this particular style of the boots, but they were able to do that. Now, that is coming from a significant difference between HinMax versus competitive products. So if you look at the thermal efficiency here, it's 3 to 4 times higher on HinMax than the competitive brand. And this is another test data. So this time we compared 200 GSM of competitive brand versus 100 GSM of our HinMax material. We were able to get the same temperature reading. So essentially, you can get the same thermal efficiency just by reducing the weight by half, which is huge advantage for the product weight, as well as the cost, because obviously 100 GSM material is much cheaper than the much less expensive than 200 GSM. So these are the examples of the different approach that we have taken and how it's paying off. So the example number 3, typical industry has been focusing on the optimum quality indicator, but HinMax has been focusing on, of course, the optimum quality indicator. You saw the CLO values of different examples, and we offer superior performances, but also we didn't forget about real life warmth and how people would feel it. And these cold spots are the issues that we need to address. And so we have breakthrough technology solutions for these. So if you actually apply our patent pending end down technology, so the improvements that you can get is actually our end down technology offers the as much warmth as temperature 3 degrees Celsius. So if you actually imagine yourself being in a room, and if you have to heat up the whole room to raise the temperature by 3 degrees Celsius, that would be a huge energy required, huge amount of energy required. And but our HeatMax technology can provide that. In terms of the CLO value, we were able to increase it by 52%. By the way, the comparison between the two here on the left and right, we use the same quantity and quality of filling material. But by just applying end down technology, you have this much improvement. And the heat distribution, obviously, you can see much lesser area of heat leak from the end down technology portion. And so that's what it shows. And just one more different approach that we have taken. So in other technologies, in this example, it's a story of down feather material. So I'll just use so we have a lot of issues using down feather material, including chemicals, maintenance, and cold spots. And in next week's webinar, I'll address all these subjects in more details. And you may be surprised to hear how many significant issues that we have to deal with the current technologies of the down feather material. But HIMMAX offers eye-down technologies which addresses all these issues, plus it can actually help you save the manufacturing cost as well. And so in this area, in this presentation, I'm going to focus on downproof. A lot of people complain about the issues of the down leaking. And if you look at this test data from IDFL, I was told that even if you buy $2,000, $300,000 jacket, most of the down jackets will give you 3 to 4, rating 3 to 4 in terms of the down leak. Obviously, 1 being the worst and 5 being the best. Before wash, it's mostly 3 and 4 rating, and after 3 washes, it drops down to 2 to 3. And in our eye down test, we got number 5 and number 5 in both before and after wash, and they put remarkable results as on the report. After this test, I asked them to do 50 washes because they were surprised because nobody has done 50 washes on the down product ever, because even after 3 washes, it drops down to 2 to 3. But we were able to get 50 washes and temperature rating 5. This was never done in the industry before. 50 wash itself is the first in the industry. Now I highlighted 3-layer here because we have 2 different levels of eye down, either 3-layer or 4-layer. That includes shell and lining material, so it doesn't change the existing structure in most part of the garment construction. And the 3-layer is a lower performance level that is used for the packable jackets. You still get level 5 rating after 50 washes. So this, once again, is never done in the industry. And this is the type of approach that we have taken to create the real value for the industry. And I'm going to cover in a couple of slides about the metrics. I mentioned earlier that CLO, fill power, these technical terms are hard for consumers and end users to understand. So this is a part of the industry's struggle to try to appeal to the consumers. Now, HIMMAX works with brands and manufacturers to create various metrics which can appeal much easier to non-experts. So examples here, we offer temperature ratings. We have 4 ratings, and cold, very cold, extreme cold, and expedition. And we also offer thermal imaging as a result. Like you, obviously, somebody in the marketing department of your company can create a hang tag or put these images on the website to explain how much the technology is. And the cost of maintenance. I mentioned briefly about this earlier in the I-down section, but we can actually provide the consumers how much savings they can create in specific dollar amount, or drying time and energy savings. So if you have a heavy down jacket, you actually have to dry it many cycles, because deep inside the jacket, if down is remaining wet, then as I said earlier, we provide the food for bacterial growth, and it will smell and it will have a bad impact on the performance as well. So it's really difficult to do a home laundry, and you have to bring it to the dry cleaning in a lot of cases. But if you are able to dry these down garments much quicker at home, doing home laundry, you're not only saving the cost, or also the environment, because dry cleaning can use a lot of harmful chemicals, but also the convenience in terms of drying time and energy savings. So we can actually provide in actual figures in terms of the minutes that they save and the dollar amount and the environmental contributions as well. So we offer so many different breakthrough performance features, and once again, some of these, most of these will be covered in future webinars. And let's talk about the environment social responsibilities before we end my presentation here. So once again, we have so many different attributes about this subject. I will give you a couple of really significant data to show you that we offer the largest energy saving technology in the global textile industry. So here, we made 2 identical jackets, one without I-down technology and the other without the I-down, meaning that conventional regular technology. And after washing and spinning before we put it in the dryer, we measured the quantity of water in each jacket. And the I-down jacket contained 60% less water in the jacket than the jacket without the technology. Now, this was quite revolutionary, according to the folks at IDFL. IDFL did this test, by the way. And so when you have a jacket with a lot less amount of water, then it takes a lot shorter amount of time to dry it. So instead of having to run the dryer several times to dry it, you can actually dry even if it's a heavy jacket, you can dry it in 1 cycle or a little more than 1 cycle. So this actually, in this particular example, we were able to shorten the drying time by 60%. And the energy that is involved, in fact, when we did the calculation of energy savings in North America only, the Canada and US, without taking in the hotels and commercial places in taking into those, just at home consumer market, we were able to come up with 2.1 billion kilowatt hour of the energy savings, which may equate to 7 or 8 coal power plant. So this is a significant energy savings, not only the convenience in the home laundry. And once again, the dry cleaning involves a lot of harmful chemicals. In fact, it's one of the main activities of Environment Canada to go after the dry cleaners and make sure that they adhere to the standards, because these chemicals are so toxic. So, so there are, multifaceted benefits with this. Now, I have run really, really quickly. I hope that I didn't make anybody uneasy. I'm wrapping up my presentation, but before I end it, I wanted to briefly introduce about uh, our new website. And I think it's the first time in the industry we built our website after COVID-19, specific application-specific content, because some of you might be interested on only in footwear or sleeping bag or heavy apparel. These are specific segments. And instead of having to go through all the website to try to find the relevant information, we actually broke down all the contents specific to application type. And also we made our website 3D model based video heavy content. So you will see our videos with the 3D models. I think it's also first time in the industry. This is done to show you how the technology works. And if you can go and visit these contents, I think you will have a lot better understanding of how things work in relation with this presentation. And you can get a wide range of technical data. And we'll post the webinar notifications there as well. And the last slide here, once again, we will post all these information about future webinars in our website, and we'll also send you the emails. Just one thing that I would like to address is that often we find that our email notification go into spam mailboxes. So if you don't get any emails in the next few days, then please go and visit our website, or you can send me an email about that, because it's on weekly occasion until the end of the month. So if you don't get any notification from us, then certainly please send me an email. So that was about it. Bob?
Only 3 minutes over. Masterful. Thank you for your presentation. So I do want to just quickly mention that, as I said before, we may have missed maybe the first slide, but the presentation is recorded and you'll receive a link to the recording in 24 hours. There are a few more questions, so I'll go through just a couple housekeeping items and then answer the questions. So if people need to leave, they'll get that. So again, there's a couple other presentations that we'll be doing with HeatMX, and of course, say as outlined, they're a very ambitious schedule going forward. And once you digest what was presented today, there'll be 2 others that we'll be doing jointly, and there'll be additional ones that HeatMX will be doing on their own. So again, lots of opportunities for further information. We do have some questions. So again, if you need to leave, leave. There's a quick survey that'll pop up on your screen as you leave. Please complete that. And that may assist both HeatMX and CAF delivering these that much better going forward. Quick comments. We got a comment from Valerio at the CTT group that said that TOG stands for thermal overall grade. So that helps answer one of the questions we got off right near the start. Okay.
Okay, thank you for that.
And again, if people, there was a couple questions about the specific testing standards, and if I may simply circulate information on the CTT group in St. Hyacinthe, south of Montreal. Clearly, they do this kind of testing because you showed their test reports on the screen. So we may do that. And again, if people have an interest in a deeper dive into that, that may be something that CTT could do with us. Couple other things. And I do think you answered this, that your standards, your sort of identifiers that you have for, very cold, extreme cold, expedition, those things. So those are based on testing, but how it correlates to -20, is that a standard or is that what you estimate?
That's a great question. Now, there is a standard, in US that relate to workwear, and we can do a temperature rating based on a standard. We also use our in-house metrics in order to enhance those temperature ratings. So basically the standard that is recognized, once again, is based on the CLO and several other factors like the activity level and things like that. But like I said earlier, the industry is lacking ways of measuring the real life warmth. And unfortunately, as far as I know, I have not seen any test method for that. So we are actually using our in-house expertise to guide our customers with those aspects. So it's a both.
And one additional question in terms of those metrics that you have, do they treat or can they take account of moisture? Because moisture has an impact. So if you said, minus 20, minus whatever, 0, minus 20, minus 30, minus 40, does that also make a representation that the normal moisture from the body, sweat, will not undermine that warmth, that insulation?
Well, you know what? I'm actually, before I answer that question, Bob, I'm actually really pleased with the level of questions that were asked, because this is quite technical. And there are so many variables. For example, the amount of sweat that our body creates vary quite a bit depending on the activity level, and also the type of garments that you're wearing, and external environment. So right now, once again, as far as I know, there's no standard way of measuring these variables and then give a fair representation of the worms. Now, we indirectly address those elements because moisture is actually an enemy for a lot of things like food or even how you feel and things like that. So the lower the moisture, the better it is in terms of how you feel comfort. And we have the technologies that show how quickly you can remove your moisture out of your body. And in fact, it is one of the important subjects that I will cover in the next seminar next week on October 8th. And so right now there is no standard method of doing that, but we actually address it pretty effectively using our HinMax technology platforms.
Okay, so generally matching the insulation value to real life applications, that's kind of the next step kind of thing. Because we do
Right.
have a couple other questions, but I think they are touching on mostly the same thing. So I think people will look forward to that. Question, are there any restrictions in terms of the channel heights of the eye down?
Oh, that's a great question. In fact, I will go back a few slides here. So one of the logos here, channel size increase, is actually a great feature that we offer for eye down and end down. Normally, there is a restriction in terms of the channel size because any loose filling material tend to settle to the bottom. In fact, it also creates the clustering issue on top of that. So channel size is a really important aspect of it. Now, our eye down and end down technology provides an ability to distribute the filling material evenly as possible based on our patent pending technology. So you can increase the channel size a lot more than the current channel sizes. So if you consider today's, you have the maximum channel size 5 inches. You cannot go beyond that. Even if you put a lot of filling material inside, you cannot go beyond a certain channel size. But you can easily increase that by 50% or even 100% because of our technology? So that is a great question. And next week, I'll cover a lot more details about this in the session.
Okay, very good. So I think that covers most of the things that I can discern. There are a couple others that probably just much better for you to decipher them and contact the questioner directly. So at this point, what I'll do is I'll conclude the webinar.